Okay, for question 6, an object A of mass moving with a speed 2u hits an object of B of mass 2m moving with the speed of u in the opposite direction to A. The coefficient of restitution is E. Show that the ratio of the speed remain unchanged whatever the radius of E. Okay, part 1. So same things you may need to draw first before you start. Okay, before and after. Before is, let's say, A, B. Okay, this one is 2m, m, and you have a negative u. Okay, into u, and after you have something A, M, B, 2m, VB, VA. Okay, before and after. Okay, so similar things, we have this kind of question will mention what is the angle, right? So you assume that this is a horizontal, okay, collision line, and same thing, you will apply the Newton's experimental law and conservation of momentum law, right, to find the answer, right? So we can try to form. Okay, the speed of approach, okay, and separation. So we have BB minus VA will be equal to E times 2U minus U, right? So by simplify, you will have 3 U and E. Okay, so this is the first equation. Second equation, conservation of energy, you have mVA plus 2mVB equals to m2u, okay, plus 2m minus u. Okay, so you have first and second equation. And the behind part, you know that when you minus will be equal to 0, and you divided by n, you should get the second equation is VA plus 2VB equal to 0. Okay, part 2, second equation, sorry. So adding the first equation and the second equation together, you may have 3VB is equal to 3EU, and VB will be equal to EU. And once you have VB, you can find VA from maybe from second equation or from the first equation, depends on you, right? It's no issue. So you have a VA equal to negative 2EU. Okay, so this is for VB and VA in terms of E and U. So question is asking you show the ratio of the speed remain unchanged but of the E. Okay, so we go to compare. So initially the speed is 2U and U, right? Speed okay, so mean 2 1, and after collision you have a 2EU compared to EU, right? So also 2 and 1. So the ratio of the speed is unchanged, always is 2 to 1. Okay, providing that E is not equal to 0. If E equals to 0 means you can't calculate already. You don't have the ratio. Alright. So now we go to part 2. Okay, part 2, find the loss of kinetic energy. Okay, so KEA1, right, before collision, we have 1 over 2 m 2u square. So you will have for 2mu square, right? So KEB1, you have 1 over 2m and u square. So you have mu square, right? So total you will have 3mu square. Okay, 3mu square for the beginning. Okay, after you will have KEA2 1 over 2 times m times 4e square u square. So 2m e square and u square, right? So KEB2 is 1 over 2 2m e square u square, e square u square, for VB, and you can have m e square u square. So you have total 3m e square u square. So the change in KE, right, will be equal to 3mu square 1 minus e square, right? 3mu square 1 minus e square. So the loss of KE, right, because of the E, right? So this is for question 6. Okay, so we will proceed to question 7, right? So before we start question 7, question 7 is involve the oblique impact of the spray. Okay, so we go through some basic principles first. Okay, for the oblique impact. Okay, let's say you have a fixed surface. Okay, and as you know that when the object is come from oblique, okay, you may have two components. Okay, two components, right? Alright, one vertical, one horizontal, so that when you have two components, okay, you will form a resultant angle when you hit on the surface. Okay, so this is before collision to the surface. So after you hit on the surface, okay, the object, okay, got component that parallel to the surface, okay, of the collision, the velocity still maintained. Okay, so this will be parallel to the surface, still maintained, and but the speed, okay, the speed of the separation, okay, the perpendicular to the surface, okay, will be equal to e v. Okay, so the e will be depends on the constitution, sorry, not constitution, restitution. Okay, so the e will be depends on the coefficient of restitution. So remember that the component that parallel to the surface of collision, okay, will be no effect, right, will maintain, will be constant. Okay, the component that perpendicular to the surface of collision will have the changes. Okay, so this is a scenario. Okay, now I will change the scenario a bit. I mean, not scenario. I will change the component a bit. Okay. Okay, still the same before and after. Okay. Now the item come with a, let's say come with a angle. Like, come with a angle. Okay. Oh, the ball is like that. With this angle. Okay. Alpha with the angle alpha, right? So you will have two components when you come. So the first component, let's say if you resolve it, you have the vertical component will be u sine alpha. Let's say the coming the approach velocity is u, the resultant u. Okay, u sine alpha, and the horizontal will be u cos alpha, u cos alpha. So after collision, okay, after collision, the vertical component will be equal to EU sine alpha. Okay, but the horizontal component still maintain U cos alpha. Okay, so this is alpha. Okay, so this is the, if you want to find, okay, the angle that leave the surface, maybe you can use the beta is equal to inverse. Right. Okay, so is equal to inverse tangent E U sine alpha over U cos alpha. Okay, so you can, it's similar to how you find the angle of resultant. Okay, so this is the things. Okay, nothing much for the oblique. Important is you can understand what the question mentioned, so that you can draw a proper how to say, the proper diagram, then you can solve it directly. Okay, so we proceed to question 7 now. Okay, question 7. A ball of mass 0.2 kg moving at 12 meter per second hits a smooth horizontal plane at an angle of 75 to the horizontal. The coefficient of restitution is 0.5. Find the impulse of the ball. Okay, so you can form, the ball is come from this direction, hit a smooth horizontal surface at an angle. Okay, so maybe it's like that. 12 angle of 45, 75. Okay, 75. Okay, for this situation, then you can form a vertical component 12 psi 75